Hello everyone, I am P. Brinda Devi and my register number is 17A019. Now we are going to see about the speed control of three-phase induction motor. So first let's see about the motor. Motor is an electric machine that converts electrical energy into mechanical energy, and the principle of motor is that when a current carrying conductor is placed in a magnetic field, it will experiences a force. And these are the types of motors. Here we are going to see about the induction motor, which is a AC motor. Induction motor. Induction motor is also known as asynchronous motor. Since AC supply is given, it is also known as AC electric motor, in which the electric current in the rotor is needed to produce the torque is obtained by electromagnetic induction from the stator magnetic field. This induction motor is a self-starting motor. Then synchronous speed. It is the speed of the rotation of the magnetic field in the rotary machine, and we know that the synchronous speed is given by ns equal to 120 f by p. So this synchronous speed depends on the frequency and number of poles of the machine. The induction motor always runs at a speed less than its synchronous speed. Then construction of three-phase induction motor. Three-phase induction motor has two main parts. They are stator and then rotor. Stator, as the name indicates, it is the stationary part of induction motor. It is made up of high-grade alloy steel, and this is laminated to reduce the eddy current losses. Three-phase supply is given to the stator winding, which is placed in the stator of induction motor. These stator windings are arranged in the form of number of slots to produce the rotating magnetic field. And then rotor, it consists of cylindrical laminated core with slots that has conductors. These conductors are made up of heavy copper or aluminium bar and short circuited by end rings. It is of two types: squirrel cage induction motor and slip ring induction motor. Now let's see about the working principle of induction motor. Motor works on the principle of Faraday's law of electromagnetic induction, that is, whenever the flux linkage changes, it produces an EMF in it. Initially, the rotor conductors are stationary. When three-phase supply is given to the stator, it produces a varying magnetic field. This rotating magnetic field induces EMF in the rotor. Since this rotor is a closed circuit, current will flow in the rotor circuit. So, we know that when a current carrying conductor is placed in a magnetic field, it will experience a force, and this force causes the rotor to rotate inside the stator. So, the rotor rotating magnetic field rotates at the synchronous speed, while the rotor rotating magnetic field rotates less than the speed of the stator. Slip. Slip is nothing but it is the difference between the stator speed, that is the synchronous speed of the induction motor, and the rotor speed, which is given by S equal to ns minus n divided by ns, where S is the slip, and the torque produced by a three-phase induction motor is given by T equal to S E2 square R2 divided by R2 square plus Sx2 the whole square into 3 by 2 pi ns. So, need of speed control. We know that motors are used in various applications which are working at different speeds. For some applications, constant speed is required, and for some other applications, different speed is required. Hence, it is very necessary to use different speed control methods of induction motor. As we know that the three-phase induction motor is a constant speed motor, it is very difficult to control its speed. So we want to implement different methods to control its speed. From the torque equation, we know that the speed of the induction motor is inversely proportional to torque, and at the starting of the motor runs at a maximum slip. and this torque is directly proportional to the slip. If the supply voltage is reduced, then the induction motor draws more current to magnetize its rotor, and so the rotor windings gets heated and gets damaged. So because of all these reasons, we have to go for the control methods for the speed control of three-phase induction motor. These are the speed control methods of induction motor. They are V by F method or frequency control method, by changing the number of stator poles, by controlling supply voltage, adding resistance in the stator circuit, and rotor resistance control. Let's see all these methods in the upcoming slides. So initially V by F control or frequency control. As the name indicates, here V by F ratio should be constant. Whenever a three-phase supply is given to a three-phase induction motor, a rotating magnetic field is produced which rotates at a synchronous speed. N is equal to 120 F by P. So here the induced EMF in the induction motor is given by E equal to 4.445 kTF, where phi is the flux, K is the winding constant, T is the number of turns per phase, and F is the frequency. And also we know that phi directly proportional to V by F. Here, if we increase the frequency, flux will decrease because they are inversely proportional, and if we increase the voltage, flux will decrease because they are directly proportional. So varying voltage and frequency is easily obtained by using the converter and inverter sets. Next, controlling supply voltage. Here the torque produced by the three-phase induction motor is given by T directly proportional to SE2 square R2 divided by R2 square plus SX2 the whole square. So we know that at initially the motor runs at maximum slip, but in low slip region this SX2 whole square is very small when compared to our resistance. So it should be neglected, and so the torque equation becomes T directly proportional to SE2 square by R2. Since we are using the constant resistance R2, the torque equation becomes T directly proportional to SE2 square. And so the induced EMF in the rotor is given by E2 is directly proportional to voltage, and so the torque becomes SV2. From this equation we can understand that if we decrease the supply voltage, the torque will also decreases, but this will increase current in the motor, which will heat the motor and causes losses. And also T is proportional to the square of the voltage, so large voltage change is required for changing the torque. By doing so, we can control the speed of the induction motor by this method. Next, by changing the applied frequency and pole, here we can determine the speed control by changing the frequency and number of poles in the induction motor. Number of stator poles can be changed by three methods, namely multiple stator winding, method of consequent poles, and then pole amplitude modulation. So synchronous speed is given by N is equal to 120 F by P. So from this we can understand that by changing the frequency and number of poles of the induction motor, we can control the speed of the induction motor. Adding rheostat in the stator circuit. Here we are going to add the resistances in the stator circuit, and due to the addition of these rheostats, the voltage gets damaged and also the voltage gets dropped. So torque equation becomes T directly proportional to SV2 square. So if we decrease the supply voltage, torque will also decreases. But we want to maintain the constant torque by supplying the same load, and it is the only possible way that we can increase the slip. And if we increase the slip of the motor will run at the reduced speed. By doing so, we can control the speed of the induction motor. And then rotor resistance control. Here the external resistances are added to the rotor side of the induction motor, and the torque equation becomes T directly proportional to S E2 square R2 divided by R2 square plus S X2 the whole square. As we know that in the low slip region, this x2 whole square becomes very small when compared to the resistance, and also we are supplying the constant voltage. The torque equation becomes T directly proportional to S by R2. To maintain the constant torque by supplying the same load, we can only increase the slip to control the speed. Here, by adding external variable resistances to the rotor via slip rings, we can control the speed of the induction motor. This is a simple method, but the disadvantage is that since there is a resistance, heat will produce which will causes the losses and decreases the efficiency of the induction motor. This method is used for wound rotor motor only. Thank you.